So what we have here is x being defined in terms of t and y being defined in terms of t. And then if you were to plot over all of the t values, you get a pretty cool plot just like this. So you try t equals 0, figure out what x and y are. T is equal to 1, figure out what x and y are, and all the other t's, and then you get this pretty cool looking graph. But the goal in this video isn't just to appreciate the coolness of graphs or curves defined by parametric equations, but we actually want to do some calculus. And in particular, we want to find the derivative. We want to find the derivative of y with respect to x. The derivative of y with respect to x when t is equal to negative 1/3. And if you are inspired, I encourage you to pause and try to solve this. And I am about to do it with you, in case you already did or you just want me to. All right. So the key is, well, how do you find the derivative with respect to x, the derivative of y with respect to x, when they're both defined in terms of t? And the key realization is the derivative of y with respect to x, is going to be equal to the derivative of y with respect to t over the derivative of x with respect to t. If you were to view these differentials as numbers, well, this would actually work out mathematically. Now, it gets a little bit non-rigorous when you start to do that, but if you thought of it that, it's an easy way of thinking about why this actually might make sense. The derivative of something versus something else is equal to the derivative of y with respect to t over x with respect to t. All right, so how does that help us? Well, we can figure out the derivative of x with respect to t and derivative of y with respect to t. The derivative of x with respect to t is just going to be equal to, let's see, the derivative of the outside with respect to the inside, it's going to be 2 sine, derivative of sine is cosine, 2 cosine of 1 plus 3t times the derivative of the inside with respect to t. So that's going to be derivative of 1 is just 0. Derivative of 3t with respect to t is 3. So times 3. That's the derivative of x with respect to t. I just use the chain rule here. Derivative of the outside, 2 sine of something with respect to the inside. So derivative of this outside, 2 sine of something with respect to 1 plus 3t is that right over there. And then derivative of the inside with respect to t is just our 3. Now, the derivative of y with respect to t is a little bit more straightforward. Derivative of y with respect to t, we just apply the power rule here. 3 times 2 is 6t to the 3 minus 1 power, 6t squared. So this is going to be equal to 6t squared over, well, we have the 2 times the 3, so we have 6 times cosine of 1 plus 3t. And then our 6's cancel out, and we are left with t squared over cosine of 1 plus 3t. And if we care when t is equal to negative 1/3, when t is equal to negative 1/3, this is going to be equal to, well, this is going to be equal to negative 1/3 squared, negative 1/3 squared over the cosine of 1 plus 3 times negative 1/3 is negative 1. So it's 1 plus negative 1, so it's the cosine of 0. And the cosine of 0 is just going to be 1. So this is going to be equal to positive 1/9. And let's see if we can visualize what's going on here. So let me draw a little table here. So I'm going to think about t and x and y. So t and x and y. So when t is equal to negative 1/3, well, our x is going to be, this is going to be sine of 0. So our x is going to be 0. And our y is going to be what? 2 over, or negative 2 over 27. So we are talking about the point 0 comma negative 2 over 27. So that is that point right over there. So that's the point where we're trying to find the slope of the tangent line. And it's telling us that that slope is 1/9. That slope is 1/9. So if we move, I guess one way to think about it is if we move 4, 1, 2, 3, 4.5 we're going to move up half. So if I wanted to draw the tangent line right there, it would look something like that. Something like that. Let's see if we go 1, 2, 3, 4.5. So yeah, just like that is pretty close. So that's what we just figured out. We figured out that the slope of the tangent line right at that point is 1/9. So it's not only neat to look at, but I guess somewhat useful.